Good afternoon, good morning, depending on where you are. First of all, can you hear me okay? Yes, very good. All right. So welcome to the Introduction to Economics revision session. The plan for today is just to go through an old exam. If you have any questions, just drop them in the chat. I know there's also a Q&A function, which I won't be monitoring, so just put them in the chat, and I should be able to react to them relatively quickly. Or if you would like, just unmute yourself and ask a question that way. Okay, so maybe before we jump right in with the content, let me say a few things about how to prepare for the exam. And also, let me just say, if you have any logistical questions or questions in terms of the format of the final exam, please just direct them. There's the first question in the chat already. Please just direct them to the relevant people in admin, as we'll just be talking about the content today and not the structure of the exam. Okay. So in general, right, so what are we looking for and how to prepare for this exam? So as in previous years, there will be shorter questions and longer questions. In general, one of the kind of key skills you should have acquired during this course is to be able to answer questions concisely and clearly using economic language. Sometimes candidates can find this quite challenging, right? Making it clear that you understand the content with a very, very precise answer, and not just giving very long-winded answers. So, you know, that does happen sometimes, that people write very long answers, which typically shows a lack of focus. And so that's clearly not a very good answer. I will give you some examples later, and you can use them to kind of prepare for the exam accordingly. Okay, second point, in terms of revision strategy, there is a tendency sometimes for people to prepare by questions, and prepare by question spotting, which means just looking at old exams and then trying to anticipate what will be examined this year. I just wanted to remind you that the whole syllabus is examinable, and then typically trying to anticipate future exam questions is not a good strategy to prepare for future exams. Right, okay. So with that out of the way, I brought some slides which contain questions and answers to the October 2024 exam. And yeah, if you don't have any other questions, let's jump right in. So there's someone who can't. So is the sound quality okay on your end? There are a few people who are asking about the sound. Okay, so it seems to be fine in general, but there are a few people with issues. So I would guess that the issue is on your end rather than mine. If the sound is low, I can try to speak up a bit, but you probably have to turn up your volume ever so slightly. Okay, so with that, let's get going. There are 120 people in there, so please keep your questions kind of concise so we can hopefully cover everyone's issues down the line. Right, okay, so section A is true, false, or uncertain, and then you have to explain your answer as well. Let's start with the first one. Okay, so question 1. In the long run, a firm's average cost curve is always U-shaped. Right? So here we're being asked about, there's a question on microeconomics, on the shape of cost curves. So the key concept here to remember is, of course, how you would derive a cost curve and where the cost curve really comes from, right? So what is the long run cost curve? Well, it crucially depends on the returns to scale of the firm. So in particular, if you have economies of scale, so increasing returns to scale, that means as you produce more, the cost of producing an additional unit falls with production. So in that case, of course, the long run cost curve is going to be downward sloping in the output space. The opposite case here is, of course, if you have diseconomies of scale, in which case the cost curve, your marginal cost of producing an additional unit is increasing in the number of units that you're producing, and in that case, the cost curve will be upward sloping. And then finally, in the case of constant returns to scale, the cost of producing will be independent of the quantities that you produce, and in that case, the cost curve will be flat, right? So here, to answer the question, crucially, the answer depends on the precise nature of the returns to scale of that firm, whether we have that U shape or not. And so the statement that it's always a inverse U is therefore incorrect, right? So even though we would typically talk about the U-shaped curve, that's not universally the case and depends on returns to scale. So a good answer to this question would provide a definition of these returns to scale or economies to scale, as I just did at the top, and then apply it to the case in hand, the shape of the cost curves in this case. So you would say there are three kinds of economies of scale which determine the shape of the curve. Therefore, it's not possible to, without knowing anything about the economies of scale, to make inference about the shape of the cost curve. Are there any questions on Q1? So someone's asking whether we should draw a graph here or not. I think in general, if you find it useful to make your point, you can draw a graph. If the graph is not explicitly requested, you don't necessarily have to draw a graph, but if it helps you with your answer, you're obviously free to do that. Because if you draw a graph, you want to explain what you're drawing as well, and not just draw something and then leave us to interpret it. Okay, very good. Anything else on Q1? Otherwise, I would move on to the next question. Very good. So question 2. So this is about game theory. Every dominant strategy equilibrium is a Nash equilibrium, but any Nash equilibrium is not necessarily a dominant strategy equilibrium. Okay, so in this case, we would need to know whether, first of all, the definition of a dominant strategy equilibrium and the requirements thereof, and also for the Nash equilibrium. And then we would need to figure out which one of the two equilibrium concepts implies the other, right? And so here the statement is that if something is a dominant strategy equilibrium, it is also a Nash equilibrium, but not the other way around. Okay. So first of all, what is a dominant strategy equilibrium? Well, that's an equilibrium in which every player plays a best response which is a best response regardless of the actions or choices of all the other players in the game. Right? So in other words, what I'm doing is completely independent of what everyone else is doing in this game, and that is the case for everyone. Right? If that is the case, we're in a dominant strategy equilibrium. Now, of course, what's the definition of a Nash equilibrium? Well, a Nash equilibrium is an equilibrium in which no player has any incentive to unilaterally deviate from the strategy that they're playing. So that's kind of trivially satisfied in the case of a dominant strategy equilibrium, right? In a dominant strategy equilibrium, I just play the same strategy, whatever everyone else is doing, hence I have no incentive to deviate from that strategy. And so by that logic, it is also a Nash equilibrium. That answers the first part of the statement, right? Every dominant strategy equilibrium is also a Nash equilibrium. That is correct. Now, the question now is whether any Nash equilibrium is in fact a dominant strategy equilibrium, right? And then that is not true. Why is that not true? Well, the strict definition of the Nash equilibrium is that the strategy that I am playing is a best response to what everyone else is playing, and so that's not necessarily independent of everyone else's choices, right? A classic example of that is, for example, the prisoner's dilemma, in which we end up in an equilibrium that might be suboptimal because players anticipate each other's choices and therefore coordinate on that equilibrium. So the second part of that question is correct, right? So not every Nash equilibrium is indeed a dominant strategy equilibrium here, right? So again, for a good answer here, you would need to explain in words what a dominant strategy equilibrium is and what a Nash equilibrium is, and then quickly discuss, as we just did, whether one implies the other. Okay. So at this point, do you have any questions on Q2? So there's a question here from Mohammed. If the answer is true, do we only explain the meanings? For example, here the definition in terms of the question. So as I was trying to say earlier, I think you would here for this particular question, you would want to explain what the concepts are. And by way of explaining that, I think you've kind of answered the question, right? But you should of course say that because a dominant strategy equilibrium, in a dominant strategy equilibrium, I'm playing a strategy independent of what everyone else does. I have no incentive to deviate, and therefore it is trivially also a Nash equilibrium. So that element should be in your explanation. So there's a question: if you only answer true, do you get partial marks? Well, you can always guess whether it's true, false, or uncertain, and you're right with probability 1/3. So I would not expect you to do very well based on just writing true, false, or uncertain. Okay, so with that, let's move on to the next question. Given that there are again a few questions in terms of the logistics and the outline of the exam, I would maybe for those who joined late, I would just reiterate what I said at the top, that if you have any questions about logistics, please direct them to admin, as we'll only be talking about the content. There are a few people who are sending questions in the Q&A function. If you could put your questions in the chat, because I'm only able to monitor one of the two. So I can't look at both of them simultaneously. Now, of course, there's another question here in terms of if you answer true, false, uncertain, incorrectly, and have a correct explanation, do you still get partial marks? Yes, in the end, what counts is your explanation and whether you've understood the concepts. Yeah. How many paragraphs are we expected to write for these types of questions? I think the types of answers that I'm showing you here should be a rough guideline of how much you are expected to write and the level of detail of the questions. Okay, so then let's move on to question number 3. Again, microeconomics question. A monopolist maximizes profits by setting its marginal cost equal to marginal revenue. Okay, so what is the problem that a monopolist is solving? Well, a monopolist decides whether or not to produce an additional unit of its output good at marginal cost. And so in principle, there are 3 situations that the monopolists could find themselves in. First, you could consider the situation where your marginal revenue is larger than your marginal cost. That means that additional unit that I'm producing and selling produces strictly positive profit, as the marginal revenue is larger than the cost of producing it. And because I'm making positive profits, I'm willing to expand my production accordingly. Now, in the opposite case, where the marginal revenue is less than the marginal cost, that additional unit that I'm selling produces a negative cash flow and negative profits. So I'm actually better off by cutting back on production and selling fewer units than I did previously. Now, as you can see with that logic, the middle case where marginal revenue is equal to marginal cost is exactly the point where I'm indifferent between producing an additional unit and reducing my production. So therefore, that is exactly consistent with profit maximization. And so again, here, a good answer, you would explain the problem that the monopolist is facing in terms of marginal revenue and marginal cost, and then conclude that in the case where revenue is equal to cost, you're exactly at the maximum possible profit. So there are, again, a few questions in terms of the structure of the exam and the precise amount of marks awarded and so on. As I said at the top, you should have been informed if there are any changes in terms of the structure of the exam, in terms of the marks. In terms of the marks awarded, if you give this is very much a complete answer to the question at hand, and so I would expect you to get full marks. Now, of course, you want to write this down nicely and not just in bullet points as I have here. There's a question from Youssef. Wouldn't it be more profitable for a firm to produce when the marginal revenue is greater than marginal cost? Exactly. That's exactly the logic that we were talking about. As long as your marginal revenue is larger than your marginal cost, you're earning more than it costs you to produce, and therefore you want to produce more, right? Only at the point where marginal revenue is equal to marginal cost will you be not expanding your production any further. Okay, very good. So here, just to say this again, right, the question was, a monopolist maximizes profit by setting marginal cost equal to marginal revenue, and in that case, that is true, and we gave an appropriate explanation. Okay, very good. So let's move on to question number 4. So question number 4, in the standard model of labor supply, the income effect of a wage increase dominates the substitution effect. Right? So here we're being tested on our knowledge of both labor supply and then what determines the relative strength of income and substitution effects in optimal choice. So, if you're approaching this question again, as in previous questions, I think it's a good way to start with defining income and substitution effects here, and then applying it to the case of labor supply at hand. So here's an example answer of how we could approach this. So think about an increase in the wage, right? That increase in wage is going to have two effects on labor supply. Right? So on the one hand, a higher wage makes it relatively more expensive for you not to work, right? So in other words, to consume leisure. That means the opportunity cost of not working has gone up. You're foregoing a higher wage per hour if you're not working. And so one response to that would be to work more. Right? It is more costly not to work, so you would want to react to that by working more. Right? That's what we usually refer to as the substitution effect. On the other hand, there is what we call an income effect. Right? So holding constant the number of hours that you're working currently, for every hour that you are working, you're becoming richer. So you earn more money for every hour that you're of labor that you're already supplying in the market. Right? That means essentially, if you wanted to reach the same level of income that you had before the increase in the wage, you could cut back on the number of hours that you're working, and therefore shift your time allocation towards, in that case, leisure, right? If that's a normal good. So if your demand for that goes up as you get richer. Right? And that means you're going to work fewer hours, right? Because you can achieve the same level of income working less. And so as you see, there are these two competing effects, the income and the substitution effect, which pull your labor supply decision in opposite directions, potentially. Now, which of the two dominates is actually ex ante and not clear, right? So if we go back to the question here, it says that in the standard model of labor supply, the income effect of a wage increase dominates the substitution effect. In other words, the income effect is always stronger than the substitution effect, right? And that's not a universally true statement. If you think about, for example, your standard backward bending labor supply curve, right? So where your labor supply increases when wages are very low but rising, and your labor supply decreases when wages are very high, then you would automatically see that the income and substitution effects dominate in different areas of the curve, right? And in particular, when your wage or your income is relatively low, the substitution effect is much stronger than the income effect, and so your hours worked rise as wages increase. But if your income is already very high, then an additional increase in wages will not incentivize you to work more, but shift towards leisure consumption, and therefore, in that case, the income effect dominates the substitution effect. All right, so in that sense, we can conclude that this statement is uncertain, and which effect actually dominates depends on your level of income. Okay, so let me go to the chat here. There are a few questions in the chat. So let me start with Mariana's question. For number 4, should we state implicitly the assumption that leisure is a luxury good if leisure is assumed to be an inferior good? Then the effect reinforce each other and the statement isn't uncertain anymore. Is that correct? For me, what makes it uncertain is the fact the assumption the type of leisure isn't stated. Is that correct? So there's a two-layered answer here. So first of all, you're partially correct saying that the key assumption here is that leisure is not an inferior good, but it is not necessarily the case it's a luxury good. It just has to be a normal good, right? So as long as your demand for more free time does not decrease with more income, the result is going to be ambiguous here. And if you now go back to the prompt, it is asking us for the standard model of labor supply. Right? And so in the standard model of labor supply, we would typically assume that that we have normal goods here and not inferior or luxury goods separately. Okay, I hope that answers your question. So then there's another question here. Are both effects, so income and substitution effects, always in opposite direction, even in cases where there's very low income? So if you go back to income and substitution effects here, even if your income is very low, right? So what was the definition of an income effect? It was just holding constant the number of hours that you're working. If your wage goes up, you're just going to earn more money with constant labor supply, right? So if your goal was just to achieve a certain level of income, you could cut back on the number of hours worked and still hit that target. So yes, that income effect will always for an increase in the wage will always decrease the number of hours that you would want to supply, right? What you have in mind here is then potentially the substitution effect. Now, of course, the strength of these effects may vary, and that's exactly what we discussed in terms of the backward bending labor supply. So then Joey is asking, what if there was a decrease in the wage? Would it remain uncertain? So for a decrease in the wage, just think about in this answer, everywhere where it says higher, we say lower, and everywhere where it says up, we say down. So for decrease in the wages, we can talk through this again, right? So let's start with the income effect. For a decrease in the wage, I need now to achieve the same amount of income, I need to supply more hours worked. Right? So in that case, the income effect is going to push you towards working more now, rather than working less, as in the case of an increase in the wage. What about the substitution effect? Well, if the wage falls, so previously said with the wage increase, the opportunity cost of not working goes up. Right? So leisure becomes relatively more expensive in a sense. And now if the wage falls, the opportunity cost of working actually goes up, right? So working relatively becomes less lucrative, and so you want to substitute away from working. The income and the substitution effect are still there, but the direction is exactly flipped now, right? So the income effect is going to push you towards more work, and the substitution effect is going to push you away from working. Okay, very good. So that concludes question 4. So let's go to number 5. So question number 5, after the UK left the European Union, many workers working in the UK left the country. This will have no short-run effect, but a severe long-run effect on the rate of growth of output per worker in the UK, all things equal. Right? And then we're prompted here to answer with reference to the solo growth model. Right. So this question really asks us to conceptualize this empirical example of the UK leaving the European Union in terms of the solo growth model. So what we need to know here is really what determines the short-run effect of a reduction in the number of workers in this model on output, and what determines the long-run effect on output in this model, right? And so we're explicitly prompted here to refer in our answer to the solo growth model. Okay. So let's think about this in a bit more detail. So what determines output in the solo growth model? Well, it's ultimately the amount of capital available relative to the stock of labor, right? And so if you have more capital relative to labor, you will be able to produce more output in that world. Okay, so how should we think about these workers leaving the country as a result of that vote? Well, it's one way to think about this is in terms of reduction of the units of labor available in the economy at that time. Right. So suppose in the short run we have a fixed stock of capital and labor supply falls, or the amount of labor available for production falls. That means effectively that the capital to labor ratio has increased. So every worker has more capital available to produce. And so because output is a function of capital inputs and the capital intensity, so the capital to labor ratio, output per worker should also rise as a result, right? So just a quick reminder here, we're being asked about output per worker. We're asking about the rate of growth of output per worker, not just of output in levels, but in output per worker. So here the tricky thing really is to think about whether that shock is a decrease in the stock of labor or a change in the growth rate of labor. And I think there was a question to that effect in the chat from Mariana. Now I agree it's a bit ambiguous here in terms of how the question is being phrased. But for the sake of the argument, let's think about a one-off decrease in the number of workers in the country, which then does not affect the population growth rate in the long run. All right, we can talk about the other case at the end if you find that interesting. Okay, so we said output per worker has to increase, and so that means that there is an increase, a short run increase in output. So if we went back to the question here, I was asking whether there should be no long run output effect. And that is of course wrong, right? We just showed that there is an output effect even in the short run here. And then you're saying there is also a severe long run effect in the growth rate of output per worker. So how should we think about the long run effects in this model? So what determines long run output? Well, as in the short run, it is the capital stock of that economy relative to the number of workers. However, there are two main forces here that drive the capital stock in opposite direction. Right? So on the one hand, as the population of the country grows, right, at some population growth rate, holding fixed the capital stock, the amount of capital available per worker falls, right? So if the population growth is larger, there are more workers being added every year to that economy, and so the capital stock will fall faster. Right? On the other hand, we also accumulate new capital through savings, right? And that is essentially, we assume that we use a fixed percentage, a fixed fraction of annual output to reinvest into the capital stock. Right? And so that leads to a higher, to accumulation of capital and to a high amount of capital available per worker. And so you have these kind of two opposing forces that draw the capital stock per worker in opposite direction. And so then there should exist a point where these two exactly offset, right? So the amount of capital added to the capital stock every year is exactly the same as the reduction in capital per worker due to population growth, right? And that is what we usually call the steady state capital stock, right? K star. That is where we're going to move to in the long run in this economy. Right. Now, how does that matter for the long run effect in this economy? If we think about a one-off decrease, or a one-off decrease in the stock of labor available at that point. Well, there are two scenarios we need to think about here. So one scenario is the case where we are to the left side of the steady state capital stock. So there's not enough capital per worker at the moment. And so we would be accumulating capital at a higher rate than capital would be falling due to population. And then on the right-hand side of the steady state ratio, we're decumulating capital faster than we're adding new capital, and so we're reducing the capital stock per worker until we reach the steady state level. All of this is, of course, assuming no depreciation, just to keep the analysis simple. Now, suppose we're at the left-hand side, right, of that steady state capital stock, and there's a reduction in the number of workers available. That increases capital per worker, and that brings us actually closer to the steady state capital stock. Whereas if we're on the right-hand side, we already have too much capital per worker, then a further decrease in the number of workers actually adds even more capital per worker, and we're going to be falling back from a higher level to the steady state ratio here, right? So crucially, which way the output effect is going to go, it depends on which side of the steady state we're on. Now, given that we're typically on the left-hand side of this steady state capital stock, a reduction in the number of workers would bring us closer to the steady state capital level, and therefore we would experience a slower period or less growth until the point that we reach that steady state. So here there would be this long run output effect, but as we said, there's also this short run effect in this case here. Now let me quickly go to the chat and answer questions on this. So Glenda is asking whether we should draw a graph here. I think you might want to draw a graph, which would probably help your explanations. If you were to draw the transition diagram, I think that would probably be a nice idea. But if you don't want to, you can also explain it verbally, as I just did. So then someone is asking, output per worker in the steady state is always zero. Is that correct? Now, output per worker is not zero, because then aggregate output would be zero, right? So then there would be no production. And we would be in a degenerate situation where there's no production and there's no savings. So output per worker is strictly positive in the non-degenerate case, right? Okay. So Pauline is asking, what does a one-off decrease mean? So we were saying in the question, it's about a bunch of workers just leaving the country. So L, the level of the amount of labor used, it used to be 100 and now it's just 80. That's it. But the growth rate is unaffected here in this case. So Mariana is saying, so in steady state, the growth rate of output per worker is always zero. Yes, exactly. That is the definition of the steady state, right? There's no more growth unless there's technological growth in this economy. But yeah, exactly. There's no this. So Joy was asking if we could quickly draw a graph here. I can try to sketch one. If you would like me to, just a brief sketch of how this should look like. So suppose here that we have capital per worker on the x-axis, right? And there is some function that tells me how quickly I am accumulating more capital, right? This would be S times Y here, right? Which we had up here, right? And then there's also the reduction in capital per worker, which comes from population growth at rate N times K. And so there exists this point of intersection here. I'm just gonna highlight that in orange color, where the two are exactly equal. Right? And so that is the long run steady state of this economy, and that defines this point K star. That is the long run steady state. Now, how should we think about a one-off decrease in the capital stock? Well, it's a one-off, if you like, decrease in the amount of capital per worker available. So say we start out in the steady state, so we move along in this direction here to this new level K. Let's call this K tilde maybe. And at this point, what is going on here? Well, this is the rate at which capital is being reduced, capital per worker due to population growth. And this is the rate at which capital is being added. And so you can see that I add more capital per worker than I lose, which means then the next period I'm going here, and then the next period, and so on, eventually going back to that steady state I started out with. Right, that's the way to think about it. Okay. So I'm going to leave that graph up for a few more minutes. There's one more question here. What if there's technological progress? Or if there's technological progress, then what you would want to do is you would want to define the steady state capital ratio, not just in terms of capital per worker, but kind of capital adjusted for the number of workers and the level of technology, which would then give you again a long run steady state in which capital relative to technology and labor is constant in that economy. as well. Okay, so what would that formula be? I guess if that would the case, you would have, instead of just n, you would have n plus g times k, defining the new point here that gives you that steady state capital stock. Okay, because I got that question, let me just say this quickly. The recording should be made available after this for all those people who have had questions about how much to write and so on. I will just refer you to the beginning of the recording where I talk about that and how to prepare for the exam and how to answer the questions. So then there's another question here in terms of what is capital deepening in this concept. Well, it's exactly this idea that you have available more units of capital per worker. So the worker has access, or per unit of labor, there's more capital to be used, and that should increase output. So in the short run, here's another question from Angela. In the short run, if there is a decrease in population, why doesn't the population growth rate change? So the way we think about this here is that you just wake up the next morning and just people are just gone, but the population growth rate year to year is the same. You could think of this equivalently as a one-off reduction in the population growth rate that then goes back, or like a negative population growth rate for 1 year, and then goes back to the level, which would give you the same results. Okay, very good. So I'm going to erase that graph now. From the slides. And if there aren't any more questions on number 5, I would move on to 6. Okay, so this is a question about international macroeconomics. If the balance of payment is in equilibrium, the current account must be 0. Right, so here we need to know the definition of the balance of payment and the definition of the current account. Right? So how is the balance of payment defined? Well, the balance of payment is just the current account. So what is the net of goods and services coming in and out of your country? That's the current account, plus the capital account. Capital and financial account is what is the net of financial flows in and out of your country. Right? So what is the amount of money being transferred into the country, out of the country? So how many bonds and stocks and foreign direct investment and so on, how much of that happens from outside into your country and how much of that is going out. That's the financial account. Okay. So the balance of payment is defined as the sum of the two. So having that definition in the background, a statement is now asking if the balance of payment is in equilibrium, then the current account must always be 0, right? Must be 0. Well, there's a special case here, right, where the current account is 0 and the financial account is also 0, and hence, because these two objects are 0, the balance of payment must be 0. And if the balance of payment is equal to 0, then it is in equilibrium. Right? So the answer would be that's a potential case, right? Current account 0, capital and financial account 0 implies that the balance of payment. However, in general, that must not be the case. That need not be the case here, because the balance of payment, of course, can be zero if the current account and the financial account, or the capital and financial account, sum up to zero, but take opposite signs, right? So, for example, a country that is running a current account surplus, so is exporting more than it is importing, but running a capital and financial account deficit, which means that there's more capital inflow into that country than a capital outflow of that country. In that case, the two cancel each other. And again, we would be in a situation where the balance of payment is in equilibrium as well. So we can conclude here that the current account does not need to be zero for the balance of payment to be in equilibrium. It just needs to be the case that the current account is offset by the financial capital and financial account. So, for example, if there is a current account surplus, it is offset by a capital financial account deficit, and if there's a current account deficit, it is offset by a capital financial account surplus. Yes. Okay, let's take a few minutes for you to write your questions on this in the chat. Okay, so let's start from the top here, whether it's false or uncertain or true, right? So the question here is, says, if the balance of payment is equilibrium, then the current account must be zero, right? So if I were to rephrase this question, an alternative way of putting this is to say, for the balance of payment to be in equilibrium, that can only happen if the current account is equal to zero. And as we just discussed, that is not the case. Now, you could say that this is actually false and not uncertain. As I said at the top, what matters really is the explanation and not whether you write true, false, or uncertain here. The only answer that is clearly not correct is if we say that it was true. So then Joey is saying, okay, can we use some real world examples here? So think about the following. Think about a country that has a current account surplus, right? So it is exporting more than it is importing. So the typical examples of these countries are countries like China, Germany, export-heavy economies, South Korea, that are exporting more than they're importing. And for their balance of payment to be in equilibrium, that means that these countries must also invest more capital and financial assets abroad that are coming into these these economies. So that's why. I go back to the example, China is investing a lot in US-based assets exactly because they're also running current account surplus. Now, the opposite case of that, for example, would be the US, which runs a current account deficit and also has larger capital and financial inflows than it has outflows. Now, a country with current account equal exactly zero just means you're exporting exactly as much as you're importing, which means you're also exporting as much capital as you're importing in that case, which seems to be more coincidental than anything. Unless, of course, you're in the degenerate case where you're not exporting anything, you're not importing anything. Okay, I hope that provides some intuition on this question. And so we have half an hour left on this session, and I would suggest we do one more question, which is question number 9. It's a longer question about utility maximization, so you get a feeling of how to answer this type of question as well. Okay, so here's the setup. There's Alex who enjoys visiting a steakhouse, who likes steak, and we're gonna be referring to steak here as X1, and also likes vegetables, and we're gonna call vegetables X2 for keep it short. And Alex's utility function is this function u that takes as its arguments the amount of steak and vegetables consumed, and is this product x1 times x2. That is the utility function. Now, we also been told here that the price of steak is 10 and the price of vegetables is 5. And then Alex has a budget equal to 100 pounds to be spent on either steaks or vegetables. Now, first question here is, what is the utility maximizing bundle? So what is the choice of steak and vegetable consumption that maximizes Alex's utility function? Okay. Next question is, what is the corresponding level of utility? So what is the number of this utility function here? And then finally, we're also asked here explicitly to draw a graph that illustrates this optimal choice problem. And we're given this hint here that mu, that's the marginal utility of good number 1, so of steaks, is x2. And the marginal utility of consuming good 2 is just x1. So by how much does my utility go up if I consume an additional unit of steak or vegetables, respectively? Okay. Very good. So I hope this setup is clear to everyone. And if that is the case, let's start by characterizing the utility maximizing bundle that Alex is choosing. Before we jump in here, any questions on this setup? Okay, very good. So let's start with deriving this utility maximizing bundle. So how do we usually do that? Well, we say that at the utility maximizing point, right, it must be the case that reallocating some of my expenditure from, in this case, steak to vegetables, but in general across goods, is not gonna improve my utility anymore. For every potential combination that I can actually afford. So how do we formalize this mathematically? Well, what is the change in my utility that I get when I shift my consumption slightly from steak to vegetables? Well, it's exactly the ratio of marginal utilities. So how much does my utility go up if I consume one additional steak and one fewer vegetable here? It's the ratio of marginal utility of steak over vegetables. And we usually call that the marginal rate of substitution. And at the optimal choice, that must be exactly equal to the relative price, right? So in other words, what I do is I look at the relative change in my utility and I compare that to the relative price right? And if those two are the same, that means I cannot improve on my utility level anywhere where I can afford to choose a different consumption bundle. So then with the hint that we're given here, that the marginal utility has this form, we can just substitute that into this tangency condition, right? So what is the ratio of marginal utilities here? Well, is x2 divided by x1, and that should equal the relative price. The price of steak was 10 and the price of vegetables was 5, so the relative price is 2 in this economy, right? Now that really says at the chart, at the point where I maximize my utility level, the ratios of marginal utility has to be equal to 2 here. Now I can manipulate that equation to arrive at the following expression: x2 is equal to 2x1. So in this case here, I would want to consume exactly twice as many vegetables as I am consuming steaks here, right? Such that the ratio of marginal utilities is exactly 2. Okay, so that is kind of my trade-off that I face between consuming more of one and less of the other, right? Now we will be drawing this in a second, but let me talk you quickly through determining the consumption bundle here. So there's a question in the chat quickly, because I think that's quite appropriate to ask now. Why is it x2 over x1 and not the other way around? Well, what we're saying here is the marginal utility from going from consumption of good 1 to 2 should be equal to the ratio of the ratio of prices, right? So the price of good 1 relative to the price of good 2. If you substitute in that particular utility function using these marginal utilities, what you get is x2 over x1. Now, you could have written this down the other way around, where you would have put the marginal utility of 2 over the marginal utility of 1, and then that has to equal the price of 2 relative to the price of 1, of good 1, right? In which case, everything is just flipped around and you end up with exactly the same expression as before. So now, how do we find the consumption bundle at that utility maximizing point? Well, I have a budget of M, right? M is 100 in our example. And that budget I'm going to fully spend on either vegetables or steaks, right, at prices P1 and P2. So that is just the budget identity. It just tells me I buy X1 units of steak at this price, and I buy X2 units of what was the other one? Vegetables at this price, and that has to be equal to my total budget, right? And so if I'm substituting in here for the prices 10 and 5, and for the budget 100, I have a second equation that determines x1 and x2, and now what I have is a system of 2 equations and 2 unknowns, x1 and x2. So an easy way to solve this is to use this tangency condition that we've just derived up here and substitute it in for x2 into that budget constraint. So then we have 10x1 plus 5 times 2 times x1. So that is 10x1 plus 10x1, so 20x1, equal to my total budget 100. And 100 over 20 is 5. So I've now determined that I'm going to consume 5 steaks. And given that I know that I'm always going to be consuming twice as many vegetables as I'm consuming steaks, I can just substitute that 5 into this expression, and I've learned that I'm going to be consuming 10 vegetables here. Okay, and so we've concluded that the optimal bundle is 5 steaks and 10 vegetables. So let me show you how to do this graphically now, okay? I hope the logic of what we've just derived is reasonably clear, and then we can illustrate that. Graphically in a second. So let me first draw our coordinate system here. This is not very nice. Let's do this quickly. Okay. So here's our system, right? And I'm going to put x1 down here. And I'm going to put x2 up here. Right? So the number of steaks is on the x-axis and the number of vegetables is on the y-axis. Right. Now, what's the next thing I would like to draw here? Well, it's probably going to be that budget constraint here, right? And that budget constraint just tells me my total spending on steaks plus my total spending on vegetables is equal to my budget. Okay. So I can solve that equation for example, x2, right? So I could write x2 is equal to, what is it equal to? M, right? My total budget over P2 minus P1 over P2 times x1. Right. So how did I get that? Well, I have this equation. I subtract P1 x1, and then I divide by P2. Right. So now I have a function of x2 as a function of x1. Right. So what does that tell me? Well, that tells me how much of x2, how many vegetables I can consume for any amount of steak that I'm consuming. And so there's a special point here, of course, which is if I consume no steaks whatsoever, I will be able to consume m over P2 units of vegetables, right? So I can indicate that point on the y-axis, the x2 axis here. Right? So what is the maximum possible amount of vegetables I could ever consume? Well, it is 100 divided by the price of vegetables. The price of vegetables is 5, so that is 20. Right? So 20 vegetables, that's the maximum amount I can consume. All right, so what about steak? Well, I can do exactly the same thing here, right? And I can say, okay, so how much steak could I at most consume? Well, it's going to be m over P1, right? So suppose I spend my entire income on steak. The price of steak is 10. I have 100. So the price of steak is, it's 10. I have a budget of 100. So that means at most I can buy 10 units of steak. So let me put that point here. Now, all the other combinations of steak and vegetables that I could potentially consume are given by this function here, right? Which is a linear combination of the two. And so I can draw a straight line here that connects these points. Right, and so on that line is every potential combination of steak and vegetables on here, right? So Angela is asking, how did I get the 20? Well, the 20 is the maximum amount of vegetables I can consume. So I said x0, x1, the amount of steak equal to 0, right? I have m equal to 100, my budget is 100, and the price is 5, and so 100 divided by 5 is 20, and that's therefore the maximum amount of vegetables I can buy, and so I put that at this point here where x1 is equal to 0 and x2 is equal to the maximum. And then similarly, I got the 10 exactly by the same logic, right? So if I set x2 equal to 0, I know that I can buy at most m over p1 units of steak. M is 100, p1 is 10, and so I get the 10. Right. Then what about the minus p1 over p2 times x1? Well, that is for all the other combinations where I'm not consuming 0 of one of the two. What is the rate of transformation, i.e. the relative prices at which I can swap steak and vegetables here, right? And then that means that the slope of this curve here has to be exactly equal to P1 divided by P2. That's what we usually call the marginal rate of transformation. That is the slope of this budget line. And so that budget line gives me all the potential combinations that I can afford. Right. So now how do I find the consumption point here in this case? Well, I'm going to draw now. Yes, I did say the slope is the marginal rate of transformation. That's right. I'm going to draw now. Let me draw this in orange here. The utility function, right? And so I'm going to now try to get to the highest possible utility curve that I can still afford, right? And that is the utility function for which the budget line just touches the curve, right? That's what we just called the tangency condition earlier, right? So my utility levels are increasing in this direction, right? So every curve stands for a higher utility level, and I'm going to pick the one that I can just afford, which is the one that just touches this line. And that defines a point here at which I'm going to be consuming the utility maximizing quantity, right? So what is that point? Well, we've derived that point earlier. That is at 5 and 10, right? And so maybe let me call this point here A. Right, that is my utility maximizing point. Very good. So let me just quickly review what we did here. So we set out determining the utility maximizing bundle. We said that that bundle is going to be determined by the tangency condition, where the marginal rate of substitution between steak and vegetables is equal to the marginal rate of transformation, the relative price level. We substituted in for the utility function, and we derived how we would substitute between steaks and vegetables. Then we also have the budget constraint, which determines how much we can spend on the two. And together with that tangency condition, it delivered a solution for the amount of steak and vegetables consumed. And then we illustrated that graphically as well. Now there's a follow-up here, is how do we determine the utility level from that consumption? Well, if you were to go back here, we're given that the utility function is x1 times x2. And so given, utility function is x1 times x2, how much of x1 am I consuming? I'm consuming 5 units of steak and 10 units of vegetables, so 5 times 10 is therefore 50, and 50 is the level of utility that we would like to achieve. Here. Okay, very good. I hope that's clear to everyone. There's another question here. Should we make more than one line? I'm not entirely sure I understand what this is referring to. If this is referring to the different utility levels, you only need to draw the utility level. That is exactly tangential. So what is the marginal rate of transformation? It is exactly the ratio of relative prices. That just means in order for me to be able to purchase one more unit of one thing, how many of the other am I going to lose out on? So here the marginal rate of transformation is 2, which means to be able to buy one more steak, I have to give up 2 vegetables. Right? So essentially it says that a steak costs twice as much as a vegetable in this economy. Okay, very good. So we have 8 minutes left, which is, I think, enough to go to question B. So yeah, the question is, assume that both steaks and vegetables are normal goods for Alex. Show in a new diagram the impact of an increase in the price of meat. So let me just quickly clear my drawing and show what an increase in the price of meat does. Well, intuitively, what should happen here, right? So let me just quickly replicate what we just had here, even though I just deleted it. So this was vegetables and this was meat. Right? And we had a budget line that went something like this. And we picked a utility level on this curve somewhere here. And we said that at this point, the marginal rate of substitution was equal to the relative price level 1, P1 over P2. So P1 is the price of steak. So what happens if the price of steak goes up here? Well, that means steak is more expensive, and so I have to give up more vegetables to be able to consume the same amount of steak. So another way of saying this is that the budget line is going to shift inwards, something like this, right? So it's going to become steeper here. And that means I will no longer be able to afford that combination that I previously did. And so I'm going to pick a consumption bundle that gives me a lower utility level that is tangential here, which might be this curve, for example, with this point here. And so in that world, I did actually increase my vegetable consumption by this amount, but I also reduced my steak consumption by that amount. So of course, for any normal good, you will be, if the price of that good goes up, you will be reducing the consumption of that good. Now, whether the consumption of vegetables actually goes up or down depends on the relative strength of the income and substitution effect, which we discussed at the beginning of the webinar. Okay, very good. Do we have to do a separate graph? Yes, the question asks for separate graphs. You have to draw a separate graph. Should we show incomes and substitution effects? No, that's not necessary here. Do we need to explain the graph with words? Yes, you always. If you just draw a graph, you should also explain what the graph does here. Okay, very good. So let me conclude here with the topics. Given that there were a bunch of questions again in the chat about various things. As I said, a few people asked about examinable content. As I said at the top, I would refer you to the syllabus, which gives you exactly the everything that is examinable. And I would just remind you again that the syllabus is the examinable content, and that looking back at past questions might be helpful for practice, but of course it's not necessarily indicative of the topics that will be covered. Any other questions in terms of preparation and so on, I would refer you to the beginning of the video, which will be hopefully available later on. Okay, very good. So at that point, I would conclude the webinar for today. I hope it was useful for you, and I wish you good luck with your exam preparation. And talk to you soon.